Conception.
Limited edition.
Geniusly crafted by
Molly and Michelle.
Definition of a limit.
A limit is the value that a function approaches as the input approaches a value.
But why do we use limits?
Limits are essential to mathematical analysis, specifically calculus, and are used to define continuity, derivatives, and integrals.
Basic limits.
To find a basic limit, you simply plug in the value that the limit is approaching into the function.
Here's a simple problem. To find the limit as x approaches -3 of x squared plus 3x, simply plug in the -3 to the x values, which equals 9 plus -9, which equals 0.
Woo. 3 special limits.
1. The limit as x approaches 0 of sine of x over x will always equal 1.
2. The limit of as x approaches 0 of 1 minus cosine of x over x always equals 0. 3.
The limit as x approaches 0 of 1 plus x to the power of 1 over x will always equal e.
But what if you can't plug it in? Gasp! Discontinuity. A discontinuity occurs where the function is undefined or not continuous, so you can't just plug and chug. Instead, you must remove the discontinuity.
Some forms of discontinuities are holes, corners, cusps, vertical asymptotes, and jumps.
Graph time! So what is the limit as x approaches 1? How about when it approaches 4?
The graph is clearly not continuous, but why? I'm sure Corey can enlighten us.
As x approaches 1, the limit does not exist. However, as x approaches 4, the limit is 2. But what if there's no graph? Remove the discontinuity through factoring, rationalizing, dividing out. Let's try an example. Ha!
Bet you thought it was here, didn't you?
But it's not. Or is it? Gotcha.
To find the limit as x approaches 3 of x minus 3 over x squared minus 9, you cannot plug in a 3 for x. It gives you 0 over 0.
Gasp. There is a whole discontinuity at x equals 3.
To find the limit as x approaches 3, you must factor the bottom of the fraction, which allows you to cancel out x minus 3. This gives you 1 over x plus 3, which equals 1/6.
I exist support group. Unfortunately, no matter how much you believe, limits do not exist when f of x approaches a different number from the right of c than it approaches from the left.
F of x increases or decreases without bounds as x approaches c.
F of x oscillates between two fixed values as x approaches c. The limit does not exist.
For graphs A and C, the limit does not exist. However, although the limit does not exist for graphs B and D, you can be more specific and say that the graph of b approaches infinity and the graph of d approaches negative infinity. The
limit does not exist. It oscillates. If you're too lazy to memorize all of this, you're in luck. Let's take a trip to the ER. Welcome to La Hospital.
La Hospital. To simplify everything, use L'Hopital's rule to find the limit by taking the derivative of the numerator and the derivative of the denominator until the limit can be defined.
Example 1. The limit as x approaches 3. X minus 3 over x squared minus 9. What you want to do is take the derivative of the top, which would be 1, and the derivative of the bottom, which would be 2x. Plug in your x value, which is 3, and you get 1/6, just like the problem before.
However, you don't have to factor, which is nice. Example 2. For a more difficult problem, you can still use L'Hopital's rule. The limit as x approaches 0 of sine of 4x over 2x is the same. It equals the limit as x approaches 0 of 4 cosine 4x
chain rule
over 2, which comes out to be 4 over 2, which equals 2. The end.